Welcome back. We have a connected particle problem here, and it reads, a body of mass 8 kilograms rests on a smooth plane inclined at 30 degrees to the horizontal. It is connected to another body of mass 12 kilograms, which is hanging freely by means of light, inextensible string, which passes over a smooth pulley fixed at the upper end of the inclined plane. The string is taut. Determine the acceleration and the tension in the string when the system is released from rest. So this is the diagram for the information that has already been given above. We have an 8 kilogram mass that is resting on a smooth inclined plane at an angle of 30 degrees to the horizontal. And we have another body of mass, 12 kilograms, that is hanging freely. And these two bodies are connected by a light, inextensible string which passes over a smooth pulley here. The question is asking us to calculate the acceleration and the tension in the string. So the tension in the string will be the same since it is a single string. And if this system is released from rest, the 12 kilogram mass is going to accelerate downwards, while the 8 kilogram mass is going to accelerate along the plane upwards. So if we should illustrate that, we're going to have an acceleration of the 12 kilogram mass this way and an acceleration of the 8 kilogram mass this way. Okay? The reason being, the 12 kilogram mass is heavier than the 8 kilogram mass. So if this system is released from rest, the 12 kilogram mass is going to accelerate downwards, while the 8 kilogram mass is going to be pulled upwards along the plane. So regarding a body that is on an inclined plane, there is always a force that tends to bring the object downwards. Okay, and that force is, we can call it F. All right, so it means that the forces that are acting along the plane for the 8 kilogram mass will be the tension and the force that tends to bring the object downwards. All right, and this force, we should be able to calculate it. It is F is equal to mg sine theta. All right, but how do we derive that? We can show that by making a free body diagram. So this force that is coming vertically downwards is the weight of the object. We also have another force that is known as the reaction, and it acts 90 degrees to the surface of the object. All right, we call that R. So if I should try to create a triangle from this, we'll have the weight extended downward this way. We'll have the reaction that will come this way, and we'll have the force F that is going to act parallel to the plane, and this is how it will come. Okay, so this is R, this is F, and this is the weight. Bear in mind that this angle here, 30 degrees, will be the same as this angle here, 30 degrees. Which means we can now try to extract the triangle out. We have something like this. Okay, we have the weight, we have the 30 degrees angle here, we have the reaction, and we have the force. So Using the trigonometric ratios, if I use sine theta, which is equal to opposite divided by the hypotenuse, then sine theta is equal to what is the opposite of the angle is f divided by the hypotenuse, which is the longest side, is w. So we will have f is equal to w sine theta. But we know that weight is equals to mass times gravity. So therefore, F is equal to mg sine theta. And this is always the force that tends to bring the object downwards, okay? It is always going to be acting downwards along the inclined plane. If we use cos theta is equal to adjacent divided by the hypotenuse, then cos of theta is equal to the adjacent is r. Adjacent to this angle is r divided by the hypotenuse is w. So we'll have r is equal to w cos theta, but w is equal to mg, right? So therefore, r is equal to mg cos theta. So if they ask you to calculate the reaction on the block or on the 8 kilogram mass, then reaction is equal to mg cos theta. All right? So you have now seen how this F is equal to mg sine theta. Okay? We have said that for the 8 kilogram mass, the two forces that are acting to move it along the plane will be the tension and the force F that always try to bring the object downwards. And for the 12 kilogram mass, the two forces that are going to act on it will be the weight, which always try to bring it downwards vertically, and the tension. So what we need to understand here is the 12 kilogram mass is heavier than the 8 kilogram mass. So if this whole system is released from rest, the 12 kilogram mass is going to accelerate downwards and the 8 kilogram mass is going to accelerate upwards. So we are now ready to solve the problem. Solution: let the 12 kilogram mass be M1. Okay? So, but for the 12 kilogram mass, we know that the weight must be greater than the tension. So it means weight minus tension will give us mass times acceleration. So the weight, we know that is equal to mass times gravity. In that case, it will be m1g minus the tension is equal to m1a. So what is m1? Is 12 kilograms. So that will be 12 times acceleration is 10 minus t is equal to 12a. So that is 120 minus t is equal to 12a. Okay? So we can make t the subject of the formula by saying 120 minus 12a is equal to t. Therefore, t is equal to 120 minus 12a. And this can be equation 1. Moving on, for the 8 kilogram mass, we said that it is going to accelerate upward. So it means the tension must be greater than the force F. All right? So let the 8 kilogram mass be M2. And we know that for the 8 kilogram mass, the tension must be greater than the force that is trying to bring the object downwards. So in that case, tension minus the force is equal to mass times acceleration. That will be tension minus F is mg sine theta is equal to ma. So, but because we consider it to be m2, that will be m2g sine theta is equals to m2a. That is to say, tension minus the mass is 8 times gravity is 10, sine theta is 30 degrees is equal to 8a. Tension minus 8 times 10 is 80, sine 30 is equal to 8a. That will be tension minus 80 sine 30 is 40 is equal to 8a. Then tension is equal to 8a plus 40. This can be equation 2. So because the tension is the same, so it means we can equate equation 1 and equation 2. Equating equation 1 and 2, what is equation 1? Tension equals 120 minus 12a. So that is 120 minus 12a must be equal to, equation 2 is 8a plus 40. So collecting like terms, we'll have 120 minus 40 is equal to 8a plus 12a. 120 minus 40 is 80. This is equal to 8a plus 12a is 20a. So if I divide both sides by 20, acceleration will be 4 meters per second squared. So we can use any of the equation, whether equation 1 or equation 2, to find the tension. Using equation 1, which is tension is equal to 120 minus 12a, that will be 120 minus 12 multiplied by 4. So tension will be 120 minus 12 times 4 is 48. So 120 minus 48 is 72. Therefore, tension is 72 newtons. If at all we want to use the equation 2, using equation 2, which states that tension is equal to 8a plus 40. Tension is equal to 8a plus 40. That will be 8 into the acceleration is 4 plus 40. 8 times 4 is 32, then plus 40. 32 plus 40 is 72 newtons. And that answers the question. Thank you very much for listening to this video. If this is the first time of visiting the channel, please subscribe, like, and share the video.